Alright, as the title of this video suggests, we're going to talk about Lewis dot structures. This little short presentation here is kind of an overview for a series that we're going to do on actually going in and drawing the Lewis dot structures for different compounds and ions. What we're going to do in that is, in each case, I'm going to make a short presentation giving you an example. We're going to work through it step by step, going through all the steps that we have, and then I'm going to put one up for you to practice, let you draw it out, and then the next slide will come up with the thing completely worked out, and we'll just kind of quickly talk through it to see if you get the same structure that we did when we did this. So that's kind of how it's set up. Now, I'm going to suggest that if you have not already looked at video 3B entitled Drawing Lewis Structures, you need to go back and look at that first probably. It's a PowerPoint presentation just giving you the overview about Lewis structures, what they do and what they don't do, introducing you to this NASB method for doing it, talking a little more in detail about some of the things involved in the NASB method. And then you might come to this next set of about 6 short videos to watch. So before we launch out into those, I do want to go ahead and pull up the next slide. We're going to quickly review the NASB method. Now, this is not a detailed review. This assumes that you've kind of looked at video 3B before you've done this. So if you've thought about the NASB method, where we're talking about the needed electrons, the available electrons, the shared electrons, and the number of bonds that are going to be in our compound, I would again suggest that you look at these 7 steps, memorize them, and use them in this order as we draw Lewis dot structures for the class you're enrolled in, whether it's Chem 104 or Chem 111 or some other chemistry course in which you're doing this, but do that. All right. What we need to do first is go through your NASB steps for each molecule or ion that you're asked to draw. I can't say enough about doing that. At least it puts you on the right track. N, needed, A, available, and S, shared electrons, and B, the number of bonds, the minimum number of bonds that we need to show in our formula or in our compound. Remember that bond number is the minimum we need to show. We may exceed it, but we can't ever have less than the bonds we've calculated. The next step after we've done NASB is to choose our central atom. Again, we're going to look at the rules for that. Least electronegative. Carbon, if it's there in the compound, put it in the center. It likes to be there. If it's the only atom of its kind, it needs to be in the center probably. Hydrogen's never in the center. And remember, the halogens don't like to be in the center unless they have no other choice, unless everything in there is a halogen or it's the only one of its kind. Third step, draw a symmetrical structure using all, and I underline all, the other atoms in the formula. All right? Best way to put 2 things around an atom is 180 degrees apart, 3 things sort of in a triangle shape, 4 things, what, top, bottom, left, and right, 5 and 6, you just got to get them around there in some symmetrical pattern. But the key here is all the other atoms. You've put the central atom down. Now every other atom in that formula has to be arranged around the central atom. You can't leave out atoms. You can't add extra atoms. Step 4, as soon as you've done that, draw a single bond to all those atoms. And if you need to, go back and use double and triple bonds. Okay? If you calculated a bond count of 4 and you've put 3 other atoms around it, drawn a single bond, you've got to use 4 bonds, so you're going to have to double up someplace or maybe triple up in someplace. Remember, there are only certain elements that can do that. Everybody remember what those are? Sulfur, carbon, oxygen, nitrogen, and maybe silicon. All right. Step 5, go back to your available electron count and assign those electrons starting on the outer elements until they have an octet, except, of course, for hydrogen. Assign an octet out there to everybody. Step 6 is check, after you've assigned an octet to all the outer atoms, check how many you've used against the available number. If you have extra electrons, and I say extra, not They're not really extra, they're part of the formula, but they're not used on the outside elements. If you have extra electrons, they have to go on the central atom in pairs, not one here, one there. You got to assign them in pairs to the central atom. And step 7, if you're drawing an ion, put brackets around the structure when you get it drawn and show its charge. All right, so you got the structure drawn in here. You got to put brackets around it, and you have to put the charge, like a -1 or a -2 or a -3 or a +1 or a +2, depending on what the charge is. It needs to be outside the bracket to get full credit for drawing the right ion. All right, so here's what's going to happen. The next set of videos are going to be labeled 3D 1, 2, 3, 4, 5, or 6, and they're going to cover these topics. 3D1 is going to just be kind of simple compounds, compounds that don't have a hydrogen or hydrogens in it. All right. 3D2 is going to be compounds, fairly simple compounds that do contain hydrogen atoms. All right. And the difference here is, especially in our needed account, everybody needs 8 except hydrogen, which needs 2, so we have to do some calculating up there when we calculate the needed and available. We got to look at that too. 3D3 is going to cover compounds that are going to have multiple bonds. Again, we may have come up and said we need 4 bonds, but when we've assigned single bonds, we've only used 3, so we've got to look at where the multiple bonds are going to go. 3D4, compounds with extra electrons. Those will be compounds in which we've assigned octets to every atom on the outside, and we've got extra ones or we still have available electrons that need to be assigned, so we're going to have to put those on the central atom in pairs. 3D5 is going to talk about compounds which violate the octet rule for the central atom. We're going to find that some atoms, when we go through this process, are going to have more things bonded to it than what the bond count that we would think, but that's okay. Some of the central atoms can expand their valence shell. We may have talked in class about hybridization, but that's okay. We have to do what the formula says. All right. So we may violate the octet rule on the central atom, either by the number of atoms bonded to it or by having to assign some available electrons there. And the last one, 3D6, is going to cover ions because we need to practice those. So again, the format's going to be, we're going to work an example. Now, most of the examples we're going to work are the ones on the worksheet that you have assigned with this lesson. There may be 1 or 2 that are a little off, but most of the ones are on that worksheet. And then we're going to follow, like I said, with a practice one. I'm just going to write the formula for you, let you practice it, and ask you to come back and then check your drawing with the one that I've done to see if you're right. Okay, well that's going to end this one, and we'll get on to the video series then.